Approximately 70,000 years ago, small groups of Homo sapiens began leaving the African continent in what archaeologists now recognize as one of the most consequential migrations in human history. Genetic evidence suggests that all non-African populations today descend from these pioneering groups, numbering perhaps only a few thousand individuals. Archaeological evidence from sites along the Red Sea coast indicates that early migrants likely followed coastal routes, exploiting marine resources as they expanded into the Arabian Peninsula. Stone tool assemblages from Jebel Faya in the United Arab Emirates, dated to roughly 125,000 years ago, suggest even earlier attempted migrations, though most scholars agree the major successful expansion occurred around 70,000 to 60,000 years ago. These migrations were not random wanderings. Climate data from ice cores and sediment analysis reveals that humans timed their movements with environmental shifts, expanding during wetter periods when resources were abundant and migration corridors opened. The archaeological record shows that by 50,000 years ago, human populations had reached Australia, demonstrating remarkable adaptive capacity and technological innovation, including the development of seafaring capabilities. What drove these ancient peoples to leave familiar territories? Most researchers point to a combination of factors: population pressure, climate variability, and the inherent human capacity for exploration. Genetic bottleneck analysis suggests that the migrating population may have faced near-extinction events, with some estimates indicating the entire human population outside Africa descended from as few as 1,000 to 10,000 breeding individuals. The physical evidence of this migration comes from diverse sources. Mitochondrial DNA studies trace maternal lineages back to common African ancestors. Y chromosome analysis reveals paternal migration patterns. Stone tools, shell beads, and ochre pigments mark the path these early humans traveled, showing increasing cultural complexity as they moved across continents. If you're fascinated by how our ancient ancestors shaped the world we live in today, please like this video, subscribe to the channel, and share your thoughts in the comments below. What aspect of early human migration intrigues you most? Your engagement helps us continue exploring humanity's remarkable story. By 45,000 years ago, human populations had spread across vast distances, reaching Europe, Asia, and Australia. Archaeological evidence from Willandra Lakes in Australia confirms human presence by at least 50,000 years ago, requiring sophisticated watercraft to cross the Wallace Line, a significant biogeographical boundary. The colonization of Europe brought Homo sapiens into direct contact with Neanderthals, who had inhabited the region for hundreds of thousands of years. Genetic analysis published in leading journals reveals that modern non-African humans carry 1 to 2% Neanderthal DNA, evidence of interbreeding between the species. Sites like Bacho Kiro Cave in Bulgaria, dated to 45,000 years ago, show the earliest presence of modern humans in Europe. In Asia, migration patterns became complex and multi-directional. Archaeological evidence from sites in China, such as Tianyuan Cave near Beijing, 40,000 years old, demonstrates early settlement. Some researchers debate the exact timing and routes of migration into East Asia, with competing theories suggesting both southern coastal routes and northern inland corridors. The colonization of Americas represents the final major landmass to be colonized by humans. Most scholarly consensus, based on archaeological and genetic evidence, places the first human arrival in the Americas between 15,000 and 20,000 years ago, though some sites claim earlier dates that remain under active debate. The Bering Land Bridge, exposed during the last glacial maximum, when sea levels dropped approximately 120 meters below present levels, provided the corridor for migration from Siberia. Stone tool technologies varied across regions, reflecting both cultural transmission and independent innovation. The distinctive Clovis points of North America, the blade technologies of Upper Paleolithic Europe, and the microlithic industries of South Asia show how human populations adapted toolmaking to local resources and hunting requirements. The transition from mobile hunter-gatherer societies to settled communities represents one of humanity's most significant behavioral shifts. Archaeological evidence suggests this transition occurred independently in multiple locations between 12,000 to 10,000 years ago, closely following the end of the Pleistocene epoch and the beginning of the Holocene. The Natufian culture of the Levant, dated to approximately 15,000 to 11,600 years ago, provides some of the earliest evidence for semi-sedentary settlement. Excavations at sites like Ain Malaha reveal circular stone structures, storage facilities, and intensive use of wild cereals, preconditions for the agricultural revolution that would follow. Climate played a crucial role in enabling sedentism. The Younger Dryas, a brief return to glacial conditions around 12,900 to 11,700 years ago, may have actually accelerated agricultural experimentation. Some researchers propose that climate stress forced populations to intensify food production through deliberate cultivation rather than relying solely on wild resources. The concept of the Fertile Crescent encompasses the region where agriculture first emerged: modern-day Iraq, Syria, Lebanon, Israel, Palestine, Jordan, and parts of Turkey and Iran. Archaeological evidence from sites like Abu Huraira in Syria shows a clear transition from wild plant collection to domesticated grain cultivation around 11,000 years ago. Resource abundance in river valleys made these areas particularly attractive for settlement. The predictability of annual flooding in regions like Mesopotamia, the Nile Valley, the Indus Valley, and the Yellow River Basin provided reliable water sources and nutrient-rich soil deposits that supported agriculture. The development of agriculture represents what archaeologist V. Gordon Childe termed the Neolithic Revolution. This transformation occurred independently in at least 7 regions worldwide: the Fertile Crescent, 11,000 years ago; China, 9,000 years ago; Mesoamerica, 8,000 to 5,000 years ago; the Andes and Amazonia, 8,000 to 5,000 years ago; Sub-Saharan Africa, 5,000 to 4,000 years ago; and Eastern North America, 4,000 to 3,000 years ago. In the Fertile Crescent, archaeological evidence shows the domestication of einkorn wheat, emmer wheat, and barley occurred around 10,000 to 9,000 years ago. Animal domestication followed similar timelines. Sheep and goats were domesticated around 11,000 years ago, cattle around 10,500 years ago, and pigs around 9,000 years ago. These dates come from morphological changes visible in archaeobotanical remains and animal bones. The process of domestication was gradual, not sudden. Genetic analysis of modern crops compared with wild relatives reveals that domestication involved selecting for specific traits over many generations: larger seeds, non-shattering seed heads, reduced seed dormancy, and loss of natural seed dispersal mechanisms. Agriculture fundamentally altered human demography. Settled farming communities could support larger populations than mobile hunter-gatherers. Bioarchaeological evidence from skeletal remains shows population density increased significantly in agricultural societies, though this came with trade-offs, including increased disease transmission and nutritional deficiencies from less diverse diets. The spread of agriculture occurred through 2 mechanisms: demic diffusion, actual migration of farming populations, and cultural diffusion, adoption of farming by existing populations. Ancient DNA studies reveal both processes occurred. In Europe, for example, genetic evidence shows Neolithic farmers from Anatolia migrated westward, but also that indigenous hunter-gatherers adopted agricultural practices in some regions. The emergence of cities represents a profound reorganization of human society. The earliest cities appeared in Mesopotamia around 5,500 to 5,000 years ago. Uruk, located in modern-day Iraq, grew to an estimated 40,000 to 80,000 inhabitants by 2900 BCE, making it arguably the world's first true city. Archaeological excavations reveal that urbanization required several preconditions: agricultural surplus to support non-food producing specialists, centralized storage and distribution systems, and administrative structures to coordinate large populations. The invention of writing in Mesopotamia around 3400 to 3200 BCE, evidenced by cuneiform tablets from Uruk, emerged directly from the need to track economic transactions. Migration played a crucial role in urban development. Cities drew populations from surrounding rural areas through economic opportunity and specialized craft production. Isotope analysis of skeletal remains from ancient urban centers shows high proportions of non-local individuals, indicating significant population movement towards cities. Other early urban centers developed independently. The Indus Valley civilization, with cities like Harappa and Mohenjo-Daro flourishing around 2600 to 1900 BCE, shows sophisticated urban planning, including grid-patterned streets and advanced drainage systems. Archaeological evidence suggests populations of 30 to 40,000 in these cities. In Egypt, urban centers grew along the Nile following political unification around 3100 BCE. Memphis, the administrative capital, and later Thebes became major population centers. However, some Egyptologists note that Egyptian urbanism differed from Mesopotamian models, with more dispersed settlement patterns. China's urban development centered on the Yellow River Valley, with cities emerging during the Erlitou culture 1900 to 1500 BCE and expanding during the Shang dynasty. Archaeological evidence from Anyang shows a city of considerable size, with specialized craft quarters and monumental architecture. Long-distance migration and trade networks connected early civilizations, facilitating the exchange of goods, technologies, and ideas. Archaeological evidence of obsidian from Anatolian sources found in sites throughout the Near East, dating to 10,000 years ago, demonstrates extensive prehistoric trade networks. The Bronze Age, approximately 3300 to 1200 BCE, saw intensified connectivity. Tin, necessary for bronze production, had limited sources, requiring trade networks spanning thousands of kilometers. Isotope analysis of bronze artifacts reveals tin traveled from sources in Afghanistan and Central Asia to manufacturing centers in Mesopotamia and the Aegean. Maritime trade expanded significantly during this period. Archaeological evidence from shipwrecks, such as the Uluburun wreck off the coast of Turkey, dated to approximately 1300 BCE, reveals the international nature of late Bronze Age trade. The cargo included copper ingots from Cyprus, tin from Central Asia, glass from Egypt, ebony from Africa, and ivory from Syria, demonstrating a truly interconnected Mediterranean world. The Silk Road, though named much later, had precursors in Central Asian trade routes dating to at least 2000 BCE. Archaeological finds of lapis-lazuli from Afghanistan in Mesopotamian sites and Chinese jade in Central Asian burials indicate bidirectional exchange of prestige goods. Linguistic analysis reveals population movements through the spread of language families. The expansion of Indo-European languages, for example, correlates with archaeological evidence of population movements from the Pontic-Caspian steppe beginning around 5,000 years ago, though the exact mechanisms remain debated among researchers. The migrations and movements of ancient peoples established the fundamental patterns of human cultural and genetic diversity we observe today. Genetic studies, using both ancient DNA and modern population samples, reveal that contemporary populations result from complex histories of migration, mixing, and adaptation. Archaeological and genetic evidence demonstrates that few modern populations descend from isolated, static ancestors. Instead, most represent mixtures of multiple ancestral groups. Europeans, for example, derive ancestry from at least three major populations: indigenous hunter-gatherers, Neolithic farmers from Anatolia, and Bronze Age herders from the steppe. The linguistic map of the modern world directly reflects ancient migration patterns. The distribution of language families, Indo-European across Europe and parts of Asia, Sino-Tibetan in East Asia, Austronesian across Pacific Islands, and Niger-Congo in Africa traces back to prehistoric population expansions documented through both archaeological and linguistic evidence. Agricultural systems established in ancient times continue to form the basis of modern food production. The crops domesticated in the Fertile Crescent, wheat, barley, lentils, peas, still provide the majority of calories for billions of people. Similarly, rice from China, maize from Mesoamerica, and potatoes from the Andes became global staples through later historical migrations and exchanges. Urban settlement patterns established in antiquity influenced long-term regional development. Many modern cities occupy sites of ancient settlements. Damascus and Aleppo in Syria, Varanasi in India, and Xi'an in China all trace continuous or near-continuous occupation spanning thousands of years, demonstrating the enduring importance of geographical advantages first recognized by ancient populations. The study of ancient migrations continues to evolve as new methods emerge. Ancient DNA analysis, isotope studies of skeletal remains, and increasingly precise dating techniques allow archaeologists and geneticists to reconstruct population movements with unprecedented detail. Each new discovery refines our understanding of how human migration shaped the development of early civilizations and, ultimately, the modern world.